Okay, so we've already reviewed some of the stuff we did last time, so let's talk about the domain and range. Here the domain is our x values, so like where are my x values? They go from what to what? It's all real numbers. So I'm going to say it's going from negative infinity to infinity. Another way to say this is all real numbers. Because I could plug in any x value and it would give me a y value every single time. It might be really, really small, right? If I plug in a negative x value, I might get a really small y, because notice our function is getting really small as we go to the left side. If I plug in a positive x value, I might get a really big number, because I'm literally taking 2 and putting it to that power. So like 2 to the 50th is 2 times 2 times 2 times 2, like 50 times. But I could plug in any number and I will get a y value. What about my range? What's my range here? All positive real numbers. So another way to say that is 0 to infinity. Notice it's parentheses both times. So I'm going from 0 to infinity, going up to infinity. All positive real numbers.
Is that an infinity sign or is it 2, 0?
It's an infinity. All positive real numbers. So this is an infinity. Okay, so that should help a little bit seeing. So transformations of exponential functions. If I have a coefficient in front of it, it's going to stretch it out. It's going to like compress my exponential, or it's going to like stretch it out. So instead of looking like a nice little exponential, maybe I might stretch it out and it's going to go up faster. Or maybe it's going to not rise as fast. So having that a in front of it, having that coefficient, is going to cause it to be like pulled up or down. Versus having a plus or minus number at the end, I'm literally going to be shifting this function up or down. Can you guys see what I'm doing? Like shifting it down, shifting it up. That's what this does. That's what the plus k does. I just move it up and down. Versus this x minus h. So if I have a x plus or minus a number in the exponent, right? If I have a plus or minus in the exponent, that's going to be a horizontal shift. So it kind of makes sense. Like when we were dealing with absolute values and squares and shifting them left and right, if I had the absolute value of x minus 2, okay, that shifts to the right by 2. If I had x minus 4 squared, right, the minus 4 is inside, like having that outlay, having that layout, like helps us see the transformation. All right, so we're going to practice this before I like set you free. We're going to practice these transformations. So here, what is the difference between this example 2 and the example we just did? The minus 2. So what is this minus 2 doing? It's going up or down, but here, how do I know which way it's going? It's going down by 2. Okay, so my asymptote used to be at the x-axis. Where is it now? It's at negative 2, because everything is shifted down by 2. Where my asymptote used to be y equals 0, now it's at y equals negative 2. So I'm just going to draw a dotted line at negative 2. All right, so this is my asymptote. Remember, asymptotes are the freeway medians. You don't touch them, you don't cross them. All right, and then intercept. How do I find my intercept again? Plug in x equals 0. So 2 to the 0 minus 2. Let's see, 2 to the 0 is 1. So 1 minus 2 is negative 1. So 0 comma negative 1. So I'll put a dot here. This is 0 comma negative 1. I'll change that color so it's clear. Let's see, Miles, put away your computer. Maya, get your headphones out. Okay. So let's go through. Let's find the values. So 2 to the negative 1 minus 2. That's a half minus 2. What's a half minus 2? Can we do that one? So let's see. 1/2 minus 2 over 1. Well, I have to have the same denominator. I need to change it. So in case you didn't realize what to do, I'm just going to multiply by this. 1 over 2 minus 4 over 2 is negative 3 over 2, also known as negative 1.5. So negative 1.5. Let's see, 2 to the 0 minus 2 is just 1 minus 2. It's going to be negative 1. 2 to the first minus 2 is 2 minus 2. So that's 0. Show your laptop. 2 squared minus 2. 2 squared is 4. 4 minus 2 is 2. Alright. So I'm going to go put these points. 0, comma, negative 1. 1, comma, 0. 2, comma, 2. Negative 1, comma, negative 1.5. So it's closer to my asymptote. So normally whenever you're using exponentials, like you'll plug in negative 1, 0, 1, because it's the easiest numbers to like figure out where you are. Maybe a negative 2, maybe a positive 2 for x. I'm going to plug in one more value, x equals 3. So 2 cubed minus 2, so that's 8 minus 2. So that's 3 comma 6. So I want you to see the curvature. I want you to see the exponential.
Wait, can they hear you?
Yeah, I'm recording it. And they can hear what you say as well.
Really?
So they like hear you say like shut your computer and stuff.
Yep.
Hi guys, hope you're having a good trip.
They're not on a... Okay. You're right. They are on a trip.
Not usually.
They are. Well, because I originally forgot that they were in Israel. I was doing the screencast for people who are gone. But you know what? It's fine.
Hope you feel better also.
Yeah, because like I thought you don't do work in this now.
Well, they have to keep up with the class. It's different.
You're not doing work.
They don't have to do the homework. They're not going to take a test. They'll just take a quiz over this because they have to know this for next year, and they have to know it for like the units later. Okay, so I connected my exponential. Nice little growth. How does this compare to the function from example 1? How is this graph compared to the graph we did in example 1? It shifted down by 2. Exactly, it's the same graph, just took everything, slid it down by 2. Meaning, so did our domain change? What's my domain here? All real numbers, right? So I can write that negative infinity to infinity, right? My x values didn't change, I just shifted my y. What is my range? Negative 2 to positive infinity. So this is why I want you to use the interval notation. That's what this parentheses I'm doing. Interval notation. Because if I just wrote all positive real numbers for the first one, what would I write for this one? All real positive numbers and all numbers going to negative 2. Like, this is a more succinct way of doing it. Yes, Mouse? Right. So we can go on to example B. How is example B different from the original example 1, where it was just 2 to the x? This is the horizontal, because notice it's inside the exponent. The minus 2 was outside the exponent. Oops. The minus 2 is outside the exponent versus this one's actually inside. Outside the exponent, vertical. Inside the exponent is going to be horizontal. So which way is this going to be going? Left or right? Which way?
Left.
Let's see. It's always, the horizontal is always the opposite of what we think. So it's going to be right. Positive by 1. Right? So 1 to the positive side. So what I'm going to be doing is taking my whole graph, shifting it over to the right by 1 unit. That's it. So did my asymptote change, or where would this be? The x-axis again. Because I don't have a vertical shift, right? I'm not moving it up or down, so it's just going to be at the x-axis. So it's y equals 0. How about the y-intercept? How do I find the y-intercept? Plug in x equals 0. All right, so 2 to the 0 minus 1. What's 0 minus 1? Negative 1. 2 to the negative 1 is the same thing as 1 over 2 to the first. So that's just 1/2. So I have 0, comma, 1/2. So I'll go to my graph. I'm going to plot the asymptote as well as my y-intercept. Okay, so this is y equals 0. It's my asymptote.
It's all 0, not 1/2.
The asymptote is at y equals 0. The intercept is right here, 0, comma, 1/2. So 0x 1/2 for y. So it's right there. Now I'm going to go through, plug in these x values, figure out what y would be. So try to figure it out that way. Like try to figure out what these would be. I'm going to go through. I'm going to write them down, but I want you to figure out, like, try it yourself. So keep in mind the first one, 2 to -1 minus 1. So if you have -1 and you're subtracting 1, that's going to be 2 to -2. So it's 1 over 2 squared, which is 1/4. All right, think you can do the rest? Oops. So I'm also throw in an x equals 3 just to see what that would be. If I had x equals 4, I just want to see, like, normally you wouldn't do this, but since I like know it works, I'm trying to show you like that we have the same curve here. 4 minus 1 is just, let's see, to the third, which is 8, 4, 8. Connect them, have this nice curve.
What's that other line for?
So I'm drawing this gray line so we can move it over and compare it to the purple.
Okay, I don't understand that y-intercept.
So I plugged in x equals 0.
So the graph shouldn't be touching the...
It shouldn't be touching the y equals 0 line. It shouldn't be touching this x-axis. If you notice, like, I got really, really close, but I was trying not to touch it. So get really, really close, but don't touch it. Really, really close.
We need a ruler.
What I'm looking for in general is, like, does your graph look like that? Or is it looking more like this? I'm looking for growth versus decay. As long as you plotted the points correctly, like, don't go like under it like that, because that's wrong. Do you see, Yarden? Don't go under it like that. Like, if you accidentally like touch it like this, like that's okay. I see the growth, right? Versus if you would come down like this, like, what is this? Like, try as much as possible to make it correct. Okay, so it's an exponential. Literally, it is the graph from example 1 shifted over right by 1. That's it. Having it in the exponent just shifts it over by 1. All right, so what's my domain? What are my x values here?
It is all real numbers and all positive numbers.
All real numbers, so I'm going to say from -infinity to infinity.
You have to do that?
Yes. And my range is from 0 to infinity. Another way of saying that is all positive real numbers. Because what happens if I have a y shift and it's not just the positive real numbers? I want you to take into account all the numbers on my graph. So I want you to be prepared for next year, especially if you're a junior. You have to use this notation. Cool. All right. Now let's talk about decay. So we've been doing growth. Now let's do some decay. It's, once again, the range is all positive real numbers, domain's all real numbers, still the x-axis. Literally, the difference is instead of coming up, it's now just going to be coming down. That's it. So let's graph it. Let's do this. Where's my asymptote? X-axis. So that's where y equals 0. So go, y equals 0, draw my dotted line. I'll label it as my asymptote. So y equals 0. And then my y-intercept, find the y-intercept by plugging in x equals 0. So if I have 1/5 to the 0 power, that's just going to equal 1. So 0, 1 is my y-intercept. 0, 1. So I put a point at 0, 1. Are we getting the rhythm? How to like go about this? Okay, so I'm gonna plug in my x values. 1/5 to -1. Wait, that just means I'm going to flip the fraction. Get rid of the negative by flipping the fraction. So this is 5/1. Wait, that's just 5. So -1, 5. Put a dot there. That's why a lot of times I use 2 and 3, because you actually can like calculate them. It's what would be, I don't know, 1/5 to the -2. Well, if I flip it, I get rid of the negative. 5 to the second power is 25, which is like way off my graph. So it's like I have to choose the numbers right by 0. That way I get nice numbers you can actually graph. All right, plug in 0. We already know what that will be because that was our y-intercept. Plug in 0. I have y value of 1. Already plotted that. Plug in 1. What is 1/5 to the 1/1 power? 1/5. Oh my gosh, 1/5 is about right here. Okay, and then 1/5 squared to the second power. That's 1/5 times 1/5. 1/25. So I'll plot this. Oh my gosh. Okay. Got to be more careful with my asymptote. All right, so 1/25 is like right here. So it really like came down fast. So my pen's too thick to like actually do the decay nicely. But it literally looks like an L.
No, take this L.
Why? That's not necessary. If you're decaying, you're losing stuff. It looks like an L. You're losing stuff. Decaying's losing stuff. Yeah. All right, what's my domain here? All real numbers. So from -infinity to infinity. So I'll say that's all real numbers. And my range? 0 to infinity. So positive real numbers. So notice the things I'm writing first is what I'm wanting you to understand, get in the habit of. Good. Okay. Okay. Bring closer. Good. That's a decay. Okay. Awesome. Let's go to the next one. So. All right, so the next one, if you look on the next page, this is like putting it all together. This is going to be the hardest one of the day. But you can do this. You can do this. What? Does what not? Okay. All right, so let's check out what's happening in this B. So this is a lot of stuff. Let's just look at it. Let's soak it in. We're gonna break it down. We're gonna break it down step by step. So first thing, what's this +2 doing? What is this doing? Right, exactly. So everything's going up by 2. When I say everything's up by 2, if I would graph 1/2 to the x, just the plain 1/2 to the x, compared to that function, this one will be up by 2. All right, and then what about right here, this x minus 1? What's happening here? Good, it's going right by 1. Right, it's going the positive direction by 1. The horizontal is always opposite of what we think. So here it's like, oh hey, guess what? Minus 1, JK, it's going positive by 1. Okay, and lastly, what is this doing? It's flipping it and multiplying it by a factor of 4. So it's going to take my growth, flip it, so it's decay, and then stretch it out. So it's going to flip it and stretch it. So the negative flips it, and this 4 like stretches it out. It's like a vertical dilation. That's what the book calls it, but I just say, okay, stretches it out. Where my value used to be a 1, now will be a 4. Where my value used to be 2, it'll now be 8. All right, so it's multiplying every single y value by 4, stretching it out. Okay, so my asymptote. Where would my asymptote be? It'd be 2. Y equals 2. Because my asymptote cares about vertical shift. It's just being shifted up by 2. So it's going to be at y equals 2. Because it used to be my x-axis. But then I have that plus 2 shift from here. That's why it's at y equals 2. Okay, so let's draw that in. Here's my asymptote. Okay. Now I want my y-intercept. So what did we do for every other problem? Plug in 0 for x. Okay, let's see what this gives us. Plug in 0 for x. Remember, plug in 0 for x. So I have negative 4 to the 1/2. 0 minus 1 plus 2. Okay, so step by step, this is going to be negative 4 to the, let's see, 0 minus 1 is the negative 1. So it's the same thing as negative 4 to the 2 plus 2. Negative 4 times 2 is negative 8. Negative 8 plus 2 is negative 6. Okay, so my intercept's at 0, comma, negative 6. 0, comma, negative 6. So that's right here. Ooh, this is a funky one, because look, it's on the opposite side. Normally we've been having our y-intercept above the asymptote, but here it's below. And asymptotes are the freeway medians. You can't touch them, you can't cross them. So my whole graph is going to be below the asymptote. So this is weird. It's what Lily said. She said it flips, literally having that negative in front, flips it over your asymptote. All right, so let's go through. Let's just plug in these numbers. Let's see what we get. So I already know, when I plug in 0, I already know what this is. So it's from the y-intercept. This is going to be a negative 6 value. Let's plug in negative 1. So negative 4 to the 1/2, negative 1 minus 1, and then plus 2. So you could plug this into your calculator if this is overwhelming for you. You can find a value that way, but like I want to see what you're plugging in. So when I say, calculator, okay, but show your work, this is what I mean. Show the setup. This is what you're putting in your calculator. Plug it in. Okay, so then we get, let's see, negative 2, 4, negative 6. So we'll get negative 14 here. No, wait, yeah.
Yes.
Yeah, negative 14. So what I wrote on the left side with the setup, that's the work I want to see when you're using your calculator. I want to see what you inputted. I want to see you guys like plugging it in. All right, so negative 14 is like off my chart. I might need to renumber my chart. Let's see what numbers I get. Plug in a 1, so negative 4 to the 1/2, 1 minus 1 plus 2. So it's negative 4 times, well, what's 1/2 to 1 minus 1? 1/2 to the 0 is just 1. Plus 2 is just negative 2. Negative 4 to the 1/2, 2 minus 1.
0.
So let's see. 2 minus 1 is 1, so a half to the first power is a half. What's half of negative 4? Negative 2. Negative 2 plus 2 is 0. Okay, so I mean, let's see what happens. Let's put these numbers on our chart. 1 comma negative 2. 2 comma 0. So if I connect them in a sort of a line, this looks really weird. It looks really weird.
Well, who cares if it looks weird? It's math.
Because remember, like, you know, 1/2 to the x power, we said it would be decay because 1/2 is less than 1. So if I flip the purple guy, if I flip it over, this is what it's going to look like. So this is like let's see, 1/2 to the x, that's what the purple is. And so this negative in front flips it over the x-axis, flips over the asymptote, and then that 4 in front stretches it out.
Oh my
Okay, so what's the domain? What are my x values for this graph? It's all real numbers, because I could plug in any
Negative
value.
Infinity and infinity. You have to write that down.
What? Negative infinity to infinity? Okay. What about my range? This is a hard one. So, we always go in like chronological order. Like I always go in numerical order from smallest to biggest. So I'm going from negative infinity to 2. Another way you could say this is y is less than negative 2. That would be okay as well.
But it never actually hits 2.
Exactly. That's why I don't have an or equal to. Oops. It is less than 2. That's why I don't have an or equal to, because it's never equal to 2. It's less than. It never touches 2. It's always less than. So you can write y is less than 2. I'll accept that. And I could go through the other ones, like here would be y is greater than 0, right? Let's see, this one ranges from 0 to infinity, so that'd be y is greater than 0. This one, it's negative 2 to infinity, so y is greater than negative 2. All right, so you can write it in inequality, that's fine as well. Okay, do we have questions? Because you have, I'll give you the rest of the time to work on your homework. Because this was good. We got through a lot of stuff. Any last questions before I stop the screencast?